Good morning all. Dear students, in the today's session I am with one more very interesting topic of SQL, that means writing of queries that we will try to exercise, because from last few sessions we have discussed many aspects of SQL, that means how to create a table, alter table, many other things, right, alter, update, like that, many basic commands of SQL, right. Then after we entered into how to retrieve a data from a table, right. So first how to create table, then how to alter, modify all such tables, right, how to update the table values, then after we entered into how to retrieve a data from a table, right, with the help of a select query. Then we discussed about the different classes of SQL, that is select, from, where, group by, having, right. Then after that we discussed about how to write multiple queries, that means how to nest a query, how to write a query within a query, right. So that we have discussed. Then after that, during that time we discussed many few operators, right. So prior to that we discussed only few operators as what we are making use in the day-to-day life, that is less than, greater than, less than, equal to, greater than, equal to, all such things, equal to, not equal to. Then after that especially when we are dealing with nested queries, there we discussed the purpose of making use of a in and not in, exist and not exist, right, all such things. And we come across with even the multi-level nesting, right, how in SQL we can achieve multi-level nesting, that means a query contains one more query and it will be enclosed by another query, right, like that we can go with any level of nesting where that SQL supports, right. So then after that we discussed about how to write a correlated queries, right. So there are two kinds of nesting. So one general nested query we call, right. The second one is that means query contains another query, subquery, that's it. Then there is one more kind of a nesting that we call by name correlated nesting, right, correlated nested queries we call. So what is the basic difference between a general nested query, because correlated nested query is also a nested query, but one small difference we have find yesterday we have discussed. What is that? That outer query table attribute can be used in the inner query, right, that is in the subquery, right, for comparison purpose or many other purpose, right. So that we have seen where it avoids that rewriting of the same table name in an inner query, that we have seen, right, so that it avoids that inclusion of one more instance of the table, right. So this is what the beauty of that. Then after that we discussed about how exactly the processing of a correlated nested query. It's a beautiful concept, right. So there we have seen that we used exist and not exist, could be we have used in the cinema DB. So which all the directors have not directed any movie, or which all the directors who directed some movies, at least one movie, for such these kind of a scenario we have solved with the help of exist and not exist, that too what, with help of a correlated nested query, right. So what we did yesterday is we used a director table in the outside, right, then in the movie table in the subquery. Then what we did is we used the director table instance, that means its attribute in a subquery, right. So that we have successfully achieved and we have successfully got the result. So that means especially when we are discussing about the processing of these correlated nested queries, we discussed that means for each row of the outer query instance, outer query table, so that will be compared with the each and every row of the inner query table, right. So this is what the beauty, the processing of that correlated nested query, right. So fine, today guys I am with one full scenario. So once after discussing these many things, definitely we are matured enough to take up the problem scenario, right. So today I am in front of you with one very interesting scenario. So by considering this scenario, let us will try to write some queries. So first in the current scenario, as a small stuff, what I will do is directly I will give a table. Before the table, definitely in Dbms, never forget guys, behind every table there is a story, right, there is a scenario. So here also in front of you we are having a plenty of tables, right, look at this one, and behind all these table there is a story behind it guys. Let me discuss the story behind this table. So the question usually, even it is here one of the practical lab session, right, you can consider, and it involves one very interesting or we can say the first step of writing of a query, we can say, especially of problem solving. The scenario is like this. They are asking us, they have given directly a table, but before discussing about a table, first what I will do is what is the story behind this table, that I will tell you. Actually, this is a database, that means they are dealing, it's a scenario related to a college or a school management system. What usually a school contains? School contains or college contains some branches, MCA, MBA, CS, IS, like that. There are some branches, right? So then after this, in each branch there are many semesters, right? 1, 2, 3, 4, many things like that, fine. Then after that, a college contains students, fine. Then student joined a college, joined for some branch. Then after that, they are studying in some semester, right? Then after that, what they will do is usually they visit a library, and in the library there could be a plenty of collection of books, right? So what they will do is they'll borrow some books from a library, right? And how in a library they maintain a books? They are having a unique number, let me call it by name, book ID for every number, because they want to keep track of each and every book, who borrowed it, on what date they borrowed, right? So all such things they want to record, right? Fine. Then after that, a student can borrow many books, and the same book can be borrowed by many students. How it is possible? Definitely it is possible, The same book can be borrowed by many students at different dates, right? It is possible. Fine. Next. And one more thing is, a student always belongs to any one branch always, right? But a branch contains many students. Fine. Next, after that, always a book having an author, one publisher, fine. Then let us assume for time being, every book having only one author. For time being, let's consider a book having only one author and only one publisher. But the same author can go for writing multiple books. Remember, a book is written by only one author and one publisher, but a same publisher or a same author can write or publish many books, right? Fine. Then after that, a branch having an HOD, right? So these are the few things. So, and student borrows books of some author, all such things. So this scenario, what the story I told you, there's a huge collection of data usually we need to store. That means huge student details, branch details, semester, the student belongs to which semester, book details, right, author details, publisher things, everything we want to store. So for that, they have given what kind of a design we can give is, so but in the scenario itself they have given directly the table, but in the next few session, in the next session what I will take up is, I will not directly give a tables. So instead of that, I will give a scenario, that problem statement as what I said now. For that we will go with designing, right? So then later we will go for writing a queries. For time being, let us assume the scenario is what I said is many students, many branches. Student belongs to a branch and he studying in some semester. There are many books written by one author, published by one publisher, right? And one author can write many books, one publisher can publish many books. A student can borrow many books at different dates or at the same date, and a book can be borrowed by many students at different dates, right? So this is what a scenario. To solve this scenario, we can go with creating a table like this, guys. All branch details, I can store it on a branch table, branch, the name of the table is branch, and having the columns, that means the attribute like branch ID, branch name and branch having an HOD, this we have taken. Then after this student, it contains USN, name, address, branch ID and a semester. Student belongs to which semester, fine. From this, look at this one beautiful thing, guys. USN, there we have viewed a branch ID, because each branch we are identifying based on what? Branch ID. Each student we are identifying based on what? A USN, right? Fine. Then after this, book table. Book contains all book details, book ID, book name, author ID, publisher, right? All such things. So when I want to know the author name, pick this author ID and go to author table, then I will get a respective name, and he belongs to which country, what is the age of author, all such things. Then after that, we are having a borrow table. What this borrow indicates, this borrow table talks about which student borrowed which book on what date, right? Because a student can borrow many books, so that we have viewed a USN and book ID here. So once if I want to know the name, take this USN, ask this USN, what is your name? Suddenly it takes us to a student table, then easily I can able to get a name. Then if I want to know the book name, take this book ID and compare it with the book table. When I go to this book table, by comparing this book ID of this borrow table with the book table book ID, then easily I can able to get a book name, right. So now as per this scenario, almost all table attributes we have given, but one thing is missing, guys. They are asking us to do that. What is that? They are asking create the following tables. We'll go with creating a tables. But prior to that, we'll try to solve the second half of this question. What is that? With properly specifying primary keys, foreign keys, and solve the following queries. Already we have come across with primary keys and foreign keys. What is meant by primary key, guys? It is to achieve uniqueness, to avoid redundancies, right? Where it doesn't permit to write a same value in the same table, right? Suppose if I have written a branch ID like 100, I cannot write 100 one more time in the same table, right? This is what the primary key meaning, right? So that we have seen. Next, foreign keys. What is the purpose of foreign key? So a student without admission, he cannot go for borrowing of a book from a library, right? This we call by name. This we can achieve with the help of this foreign keys, where it avoids sometimes redundancies, and as well as it takes the values only which are present in a master table, right? So in the transaction table, I cannot write a value of that attribute where it is, suppose if it is not present in a master table, right? That means in student table, in branch table, branch ID is a primary key. Let's assume 100 have written here, 100. So 100 and 101 I am having as two branches. 100 means MCA, let's assume. 101 means MBA, we can consider, right? Then can I able to write 200 in a branch ID column of this student? I cannot write, because this branch ID is, which is taken from branch table. That means a foreign key is one where it must be a primary key in some other table. That means under this branch ID of student table, I can only enter the values which are present in the primary key table. So where exactly this branch ID is primary key here? In the branch table, branch ID is a primary key. So for that, it takes the values only which are present in a branch table. Most of the time, the purpose of making use of a foreign key is to bridge the relationship between the tables, right? So I can connect two tables possible, and it takes only the values, only I can enter 100 or 101, and I can repeat these values many times. Since it is a foreign key, under foreign key column, I can repeat the values of its primary key table many times. 100 I can write many times. Why, So once if I write 100 thrice, it's an indication that the branch having 3 students. That's it, right? So fine. So now we'll try to make an exercise to identifying the proper primary and foreign keys, especially here. So for that I have written the same thing in terms of a table format here, right? So we'll try to pick a primary keys and foreign keys as per this example, right? So each branch is identified based on what? Branch ID. So for that ID becomes what? Yes, primary key, right? So let me call it by name a primary key. So how can I represent in a scenario? It is represented with a notation called, that means underlining that attribute that represents is a primary key, right? Here branch ID is a primary key. Fine. What next? So in the student table, first we'll try to identify all primary keys, right? In all these tables, in the student, which is the primary key? Yes, USN is a primary key. Let me underline here. Fine. Next, in the book table, which is a primary key? Book ID is a primary key. Fine. In the author table, how we are identifying author? Author ID, right? Author ID is a primary key. Let me go with this here also. Next, in the borrow table, no primary keys. Fine. So almost we have come across with almost all primary keys we have successfully identified. What's the next thing? We'll go with identifying a foreign keys now. So already we know the meaning and the purpose of foreign key. It is to bridge table and as well as to achieve referential integrity constraint. Fine. In the branch table, do we have any foreign keys? No. But in the student table, yes, we are having a branch ID which is taken from where? From a branch table. That means which are all listed here, branch IDs, that only I can enter. So for that this become a foreign key. So that how can I represent it here is, this is pointing to this one. This how the notation used always. For representing a foreign key is this one. That means this one, this branch ID is pointing to a branch table branch ID. That's it. Fine. Next, after that. So what any other foreign keys? First, let us will try to recognize in the book table we are having a branch ID. It's an indication that this book belongs to which branch, right? So that's it. So this branch ID takes us to its primary key table column, that is branch, right? So this again a foreign key. Let me go with connecting it with this one, right? Again it is pointing to branch ID. Fine. Next, any other? In the book table we are having a AID, but basically this AID book table author ID, it is taken from where, guys? From author table author ID. So for that this becomes a foreign key and it points to where? This one, right? So let me go with writing where it is, here AID, and this points to a primary key table AID, right? This one. Fine. Then after that, what we are having in the borrow table? In the borrow table we are having two key attributes. What are all? USN and book ID. But these two are what? Foreign keys. Why? I want to repeat many times this USN and as well as the book ID. Why? Suppose if I won't if the table doesn't permit us to write many times a repetitive entry of USN, if it doesn't permits, it's an indication that a student cannot borrow multiple books. But what is the intention? A student should be allowed, that means that we have to design in such a way that a student should be permitted to take multiple books, borrow multiple books, and a book also to be borrowed by many students, right? So for that, both I want to repeat many times, right? That USN and as well as book ID. So for that, these two becomes what, guys? Again, foreign key and USN. When I ask what is your name, suddenly it takes us to where, guys? To a student table USN. So for that USN becomes what? A foreign key, and it is pointing to the student table, right? Then after this book ID, this is pointing to a book table, right? So let me go with this. Yes, fine. Book ID points to book table. That's it. Anything else? No. Almost everything, right? We have completed. Now, what's our? Let's the second this much the second half of the question, that is finding primary keys and foreign keys in the given list of tables that we have achieved successfully. Next, create the following tables. We have not created a table, right? So now we are having an opportunity to create table with all primary keys and foreign keys, right? So we'll start our coding. So I have successfully already logged into MySQL. Now we'll go with first, before creating a table, what is needed? We need to go with creating a database, right? How to create a database? Create database, right? So let me give some name. Let me call my name MyDB1, right? MyDB1. Let me give, fine. So already cannot create database. It's saying it is already existing. Let me give some name. So experiment exp1, we can give something. Yes, database created. Use, then I want to enter into my site, that is exp1. Yes, I have database change, that is it's an indication that we have successfully entered into a database, right? So what next, guys? Now we need to go with creating a table, right? How to create a table? Create table. Now which table to be created first? So this is what question we are having now. We are having a branch table, student table, book, author, borrow. Which one to create first? I can go with creating anything. So first let me go with creating a branch table. Yes, because sometimes you are having a question like this. Can I able to go with creating a student table first? I can create, but the question is that requires more amount of alter command to be used, because to make this branch ID as a foreign key, first I should have a branch table. Their branch ID must be a primary key, because an attribute cannot be made as a foreign key without making that attribute as a primary key in same or in a different table, right? So it is required. Let me go with create table. Which one? Branch table. Create table, branch. Yes, done. What all the attributes? Branch ID. Let me call it by name BID in short form. BID. How to make it as primary key? Int primary key. That's it, right? What's the next one? B name, branch name, right? Varchar, it is of string type. Then what next? HOD. This also I want to make it as varchar with some 20. I can give yes, done. I am ready with the first table, branch. Let me go with describing a branch table. Describe branch. Yes, I got the branch table with where BID, branch ID as primary key. Fine. But the next table to be created, student, where USN is a primary key and a branch ID is a foreign key, and it should point to a branch table. Let me go with creating create table branch, sorry, not branch, student, right? Student. There I want to make this USN int, and this I want to make it as primary key. Yes, done. What's the next step? Next step is to make this name, address, branch ID that I want to define. Name varchar of some 20. Then what next? Address varchar of 20. What next? I want to have a branch ID that called my name BID int. Fine. Then after this sem int. Never forget, once after writing, let me go with making one more thing we have missed. What is that? This branch ID, I want to make it as foreign key, and it should point to branch table branch ID. So that, how can I make? Foreign key of BID, right? Foreign key of BID. This represents foreign key of BID. This statement represents the current table. This BID represents the current table defined BID, this BID. And it should point to where, guys? References. It should refer where? Branch table branch ID. References branch of BID, right? So that's it. Semicolon, enter. Yes, we have done with the things. Let me go with describing. Describe branch. Yes, done. So this we have made this, sorry, not branch. Which one? Student we have created, right? Student. Yes. In the student USN primary key, yes, done. And branch ID, BID is a foreign key. So that we got MUL. Fine. Let me go with the next table. What is that, guys? Book table. Whether to create book table first, author table first. So when I go with book table, later I should make use of alter command to make this AID as a foreign key. So instead of that, what best we can do? Go with author table, then go with a book table, right? So because in author table, we don't have any foreign keys, right? So once if I created AID with primary key in author table, then after when I go with the book table creation, easily I can make this as a foreign key with a create table treatment, right? So that we can do. Let me go with creating create table author. Fine. What is that? AID int, and I want to make it as primary key. Yes, we have done. What next step? A name. Done. What next? Country. Fine. Then after this age int. Done. Yes, we have done. Let me go with creating the next table. What is that? Book table, right? So create table book. There book ID is a primary key, BK ID I can call int primary key. Have written. Yes. What's the next step? BK ID primary key over, then book name, author ID. Those things I want to have. Book name, I'll call it my name BK name. Fine. Varchar of some 20 string, right? Fine, done. Next, author ID, AID should be of integer type. Yes. Next, publisher, varchar. Next, branch ID. Oh, branch, again a foreign key, right? So that we can make BID int. So there are two foreign keys. Look at this one, guys. Can we have a multiple foreign keys in a table? Yes, sure. We have come across with a scenario where a table can have more than one key attribute, more than one attribute as a foreign key, right? Here, one AID should point to author table, and branch ID where it is pointing to branch table, right? So what to do, how to achieve? Simple, as usual, go with foreign key of what? EID. This represents, this is an author ID which is defined in the current table, that is in a book table. This one here, look at this one, EID we have mentioned, that EID, this one, right, foreign key of EID, and it should points to where, guys? This EID should pointing to where? To author table EID, right? So that's it. So references author of EID, that's it. Look at this one. Then it's over. Put a comma. Then after this, because still things are not completed, because we left out with one more thing. Even we need to make this branch ID also as a foreign key, and it should point to branch table. Let me go with making one more time. Again, right? Foreign key of BID, and it should point to the references, which table? Branch table, branch ID, branch of BID. Okay. That's it. Anything left out? That's it. Let me write enter. Yes, query okay. Let me call the name describe. What is that? Book table. Yes, we got the things where one BKID is a primary key and two things, AID and BID as foreign key. We got the things, right? Fine. Let me go with the further. What is that? The last table, the left out is the borrow table. Let me go with creating this borrow table. What all the attributes it contains? One is USN, then book ID, then after this B date, right? Borrow date. So with the help of this table, we learn one more thing. That means a table with full of two foreign keys, and as well as one more thing we can learn it here is B date. I want to make use of I want to introduce one more attribute, one more data type here that we call by name date type. In MySQL, we are having a date kind of a data type. Through that, I can input a date. The format of the date to be used to input is the standard format. First year, 4-digit year I should give. Then after this, followed by 2-digit month. Then followed by 2-digit date, right? And each of them are separated by hyphen that I can make use, right? So within the single quote or a double quote that we have to make use. Let me go with create table. What is the name of the table? Borrow. So the attribute of the borrow table are USN, int, then book ID, int, then after this borrow date, right? So B date, let me call B date, and the data type till now we have not come across with this thing, date have mentioned, never forget this one, date, right? Date type. Then after this still we have to make these two attributes as foreign keys and should point to that respective table. Let me call it by name foreign key of USN references, where guys? Student of USN, student of USN, that's it. Next, foreign key of book ID should points to the book of book ID, that's it. So foreign key of book ID references, which one? Book of book ID. Yes, things are ready. Let me go with writing. Semicolon. Done. We have ready with the table. Describe book table. Yes, sorry. Borrow. Yes, we got the answer. Two foreign keys and with date type, right? This one. Let me go with inserting a values for timing. What I'll do is I'll make use of branch ID as 1, 2, 3 and so on, and USN as 10, 11, 12, that means 10 series to distinguish between each of the key values, right? And book ID I'll give a value 100, 101, even you can give 1, 2, 3 even for that also. For timing, what I'll do is I'll make use of this uniqueness, that means to distinguish whether it is a book ID or a USN, right? So for that, author ID I'll make use of 200, 201, 200 series I'll make use, right? So that easily we can able to identify what exactly this one, right, in the result set. So let me go with adding to which table I want to insert first, branch table. So always inserting first, let us will try to describe the table structure describe branch. So, contains 3 attributes. So, BID 1, 2, 3, 4 that will give. How to insert a tuple? Insert into branch, then values. What are the values? 1 branch name, let me call it by name MCA, then HOD, let us say Manju sir, enter. Next, let us will try to write a few more values to some MBA, let me add some Raju sir, yes, done. One more last one, 3 CS, some Deepu sir, let me write, select star from branch. Yes, we got the values. Fine. Let me go with inserting a tuple to a student table now. Describe student. Fine. How to insert? Again, insert command. Insert into student values. We can write. Fine. So, there for a USN already we have seen something what will use a series like 10, 11. Let me go with 10. Then name of a student, let me call it by name some Arjun. Next address will have Mysore. Then after this we are having a branch ID, and branch ID should be taken from where? From a branch table, right? From this branch table, only such values I can give. So, let me make it as 1, 1 means he belongs to MCA. Then what is the next attribute? That is a SEM. Let me call it by name semester 2. Next, let me go with adding a one more attribute 11 with Balu, then Mysore, and he also belongs to branch 1 and belongs to semester 2. Let me write. So, 12, one more student with Ramu, then I will make this semester as branch as 2 and semester as 4 something. Okay, select star from student. Yes, we got the thing. Look at this one. 10, 2 belongs to branch ID 1 and 1 belongs to branch ID 2. Fine. Then after this, let me go with adding one more table, values, whether to insert a value for author table first or book table first. So, not a book table that we can do, but for during the time we need to fill a null value, null under the column AID, but instead of that what best we can do is first go with inserting a value for author table, so that I can take this author ID and I can write it here, right. So, for that. So, what we will do is let me go with creating a author table. Inserting a value for a author table. Yes, done. This is the attributes of author table. Describe author, we did. Then insert into author table, right, author values. So, let me give ID as 200, 201, 202 and so on. Let me 200 series, 200. Author name, let me call it by name some Navate. Then after this country, let me write some India. Age, right, let me call by name some 45, enter. Let me go with adding few more values, 201. So, author name is some Raghu. He also belongs to India with some age, let me call by name some 50, enter. Last value, let me write 202, some Manu, so let me call my name USA, right, America will have, and 45 something, yes, select star from author, yes, we got the data with respect to author, yes, done. Let me go with adding a value for inserting a tuple for a book table now. First, I will try to describe book table, book, fine. So, there are many values I want to insert. Let me go with inserting a value, insert into book values. So for a book ID, we will have a series like 100, 101 and so on, 100. So book name, let me call it by name Dbms. Next author ID we have viewed a series 200, 201, let me call it by name 200. And publisher, let me call it by name Sir Sapna, right? Publisher, something you can have, Tata McGraw, anything you can make use. Branch ID, let me call this as 1, that's it. Let me go with inserting one more tuple, 101. So it is DS and written by same author, publisher is also same, we can have and belongs to same branch. And 102, let's say C++ we can write and written by 201. So published by some Tata, let me have. So belongs to some branch 2. Select star from book. Yes, we have some data here. Then what's the next step? Let me go with inserting a tuple for a borrow table. Describe borrow, insert into borrow values, the last table will have. So what are the attributes we are having actually? So USN, book ID, B date. So USN we have viewed a 10, 11, 12, 10 series. Let me call the 10, USN 10 borrowed a book, book ID some 100, let me write. So 100 he borrowed and some so and so date. I said make use of either single quote or a double quote, 2020 01 02, right? In the first month, January month, in the second date, something what he borrowed, like that we have entered, yes, done. Then in the same fashion, let me make this 10 to borrow some more books, 101 on same date, or you can have a different date, no issues. Then 10 borrowed one more book, let me call it by name 102 on date 3, fine. So let me have some more students with 11, with 101, same 100, that also possible, on 4. Look at this one, select star from borrow. So with this we come to know that a student, 10 I can repeat many times, it is an indication that a student can borrow 100, 101, 102. 10 connected with 3 different book IDs, it is an indication that a student can borrow many books. And one more, 100 occurred twice in the table, right? It is an indication that the book ID 100 is borrowed by 2 different students on 2 different dates. This is also possible, right? So 100 borrowed by 10, 100 borrowed by 11, but at different dates. Look at this one. So date format, this we have learned newly, right, today? Yes. So currently in the today's session we learned behind every table there is a story, right? So every table internally having some story, right, that represents beautiful things, right, which are residing in a story, right? There are many relations, concepts, right? So it contains, so that we have seen. And after that a table, most of the table, as what all the tables we will create, so between the tables we are having some bridging attribute where we can make use it as foreign keys, right, where it avoids redundancy and all and connects multiple tables, that all we have seen. Then we discussed about the data type, right, then how to create a table, how to have multiple foreign keys, how to define it and all, right. So fine, so we have successfully identified primary and foreign keys and all. Then the relationship between the tables, that is one to many, many to one, many to many, right. So one to one also things. In the next session we will go with writing queries on this table, right. So small queries with let us from small to complex we will move. Fine, thank you, thanks for your patience listening.